Welcome to Lesson 5. This is Activity 5.2. This is out of our PS2 book. So this lab is if you were gone, if you were absent and you need to make up the lab, this is where you will do it. So the learning target for this activity is that we're going to be able to collect, analyze, interpret data for evidence of energy transfers. So we've been talking about energy conversion so far in class. Now we're going to start to talk about energy transfers. So the expectation for you is that at the end of this activity, you're going to be able to define energy transfers and learn to draw energy transfer diagrams. So that's what we're going to be getting into, and that's what we're going to be starting to work on in class in Lesson 5. So first thing I want you to do is open up your books to page 51. And if you look up towards the top, it's going to say prediction. After your teacher illustrates what he is going to do, predict what you think will happen to the larger ball and a smaller ball. So the first thing we're going to do is we're going to take a basketball. And from 50 centimeters, we're just going to let the basketball drop. Then what we're going to do is we're going to take some more measurements. And this time we're going to have a racquetball. We're going to take the racquetball from 50 centimeters and we're just going to let it drop. And we're going to record how high it bounces. So this is what is going to be interesting about the second part. Then what we're going to do is we're going to take that racquetball and we're going to place it on top of the basketball. And we're going to hold it 50 centimeters above the ground and we're going to let it drop. So the question for you is make a prediction. What do you think the larger ball will do when we place the racquetball on top of it? And then what do you think the smaller ball will do, and the smaller ball being the racquetball? And after they bounce the first time, what do you think is going to happen? So we're just looking for a quick prediction. What do you think is going to happen? Are you going to be correct? Maybe, maybe not. Is your prediction going to be way off because you really don't understand what's going on? Possibly. But just humor us and make a good prediction. What do you think is going to happen? Doesn't mean you have to be right. You don't have to spend 3 minutes, wondering what's going on. Just what do you think is going to happen? All right, so you've had a little bit of time to make some predictions. So this is what's going to happen. If you are absent, obviously you're not going to be able to do this. But what I did was I sent the entire class outside. Each class had the book because they were going to record your data. They had 2 meter sticks, a basketball, and a racquetball. Now, originally, they had a chart that looked like this. And if you look in your book, your chart looks like this. Unfortunately, Mr. Phillips and I, we thought that we should do more repeated trials than just one for each one. So what we did was we divided each of those spaces up. So if you look at this right here, you see the T1, T2, T3, and you need the T average and the T average for the second bounce. And so if you look underneath the height of bounce of basketball, what we did was we took that first column and we divided into this column. So just divide this into threes. So here's where you're going to record your data. And then divide this into threes. This is where you're going to record your data for your second bounce. So after it bounces once, it goes up. You record that first bounce height. Then it's going to go down, touch the ground a second time. And when it reaches its max height, that's where you're going to record the second bounce height. So could you do this at home? You could. Give it a try. If you got a basketball and a racquetball, why not? Go ahead. So just pause the video and record your data in your books and then come back to the video when you are done. Now, if you don't have all this at home, or it's raining or something, you weren't in class, I'm going to give you something. I want you to use this data. So go ahead, fill in this data in your chart that you just created. Now, the students who took this data didn't calculate the averages yet, because I want you to calculate the average. So go ahead, add the 3 together, 46, 43, 40, and then divide by 3 to get your average. Then go ahead and do it for the height of the bounce of the racquetball, then the basketball bounce height with racquetball, and the racquetball bounce height with basketball. Then do the same thing for the second trial. Now, once you get done with all this, again, this is what we did. We dropped it, we recorded the height, and we recorded all that in our data table. So now what you're going to do is you're going to flip to the back of the book, go to page 52, and what I'd like you to do is answer the 3 questions at the top, and then the conclusion says, in this lesson, you have been introduced to a new concept called energy transfer. Energy transfers occur when energy moves from one object to another. And it says, follow-up question, draw an energy transfer diagram. So what I want you to do is draw an energy transfer diagram for the billiards ball you observed in video 5.2. So I'm going to pause this, and then I'm going to play that video again for you. All right, so I brought up the video of the billiards ball. So on the bottom of page 52, it says draw an energy transfer diagram for the billiards ball you observed in video 5.2. So I'm going to go ahead and play it. There it is. All right, I'm going to play it again so you have a chance. Of course, it's a video. You can replay it yourself all you want. Okay, so what I want you to do now is I want you to draw an energy transfer diagram for what you think the energy transfer is within that model. Trying to get to the, okay, now you've had a chance to get that, so you can unpause the video. So that would have been number 1. And then number 2 in the bottom, this will actually be on the top of page 53. It says, in lesson 2, you dropped a heavy tin can onto a ball of modeling clay. Draw an energy transfer diagram for the tin can and the modeling clay. So if you remember back to this activity, and you can go back in your book if you want to, what do you think an energy transfer diagram would look like? What energy is being transferred? So go ahead and try and draw this. Now, when you get back to class, you can let your teachers see this, and they can help you figure out if you were doing it correct or not. Or just, check with a classmate as well, because if they were here when we went over this in class, you'll be able to compare yours to theirs. That way you know how to draw an energy transfer diagram. So again, with the data you have here, you should be able to complete lesson 5.2, and that goes from pages 51 all the way through page 53. If you have any questions, again, ask your science teacher, please.